welcome. I'm Howie Howard from Mr. Furious Records. And today on Dat Fury Radio, something completely different. I'm going to attempt a radio-style audio demonstration of a piece of equipment that I have invented/developed. There will be a visual component on YouTube for this, so if you are not subscribed to the YouTube channel or would like to hop over there for this particular episode, it's youtube.com/@DatFuryRadio, or you can search for it and watch me do this demonstration over there. But I'm going to attempt to narrate and make this work in an audio-only format, so we'll see. Let me know what you think. But the story is, back in December of 24, I successfully built a light controller, an optical controller, for my dad's Soma Lyra 8 synthesizer, and I made a whole video about that. I will link to that in the description. But right as I was finishing that, I don't remember if it was a few days before or a few days after or what, but right around the time I finished that, just before Christmas, on my YouTube homepage popped up some 10-year-old videos from Casper Electronics demonstrating and doing a DIY how-to on Schmitt trigger oscillators. Now, the Lyra 8 is a Schmitt trigger oscillator synthesizer. A Schmitt trigger is a certain type of very simple oscillator. The output of the op amp goes up and down, square wave, just up and down based on its input. It flip-flops the input and the output. Very, very simple. So I watched these videos and got super intrigued how to maybe make my own synthesizer. And I started working things out and playing around on the breadboard, and have arrived at what you see, what you're about to hear before you, the Mnevis Mk synthesizer from Mr. Furious Audio. The concept and the interface is strongly influenced by both the Lyra and the Casper Electronics Novadrone. The circuitry is a mix of, again, Casper, the wonderful Moritz Klein and Erica DIY series, and some of my own things, like the shape control in Mnevis is entirely my own design. So enough talking, let's hear something. Here is Oscillator 1. Oscillator 1 has a pitch control, of course. Very wide range, almost into LFO territory at the bottom. And it has a shape control to move the wave shape around. So it doesn't have a filter, it has this shape control instead. This is kind of influenced by the Lyra. On the far counterclockwise of the shape control, we have kind of a half triangle, half sine type of shape. Very fat, but with some harmonics. Great for bass sounds. And the shape control sweeps up through and into a kind of saw mixed with a pulse, so it's a or almost kind of an inverted shark fin. It's not the normal waves. I mean, it's not your pure sine, triangle, saw, square. It's this mix of wave shapes. Now you've been hearing the pitch go up and down. Oscillator 1 is tied to a control oscillator, or LFO. it has a rate, so we can affect how fast the pitch is changing on the audio oscillator. Into the low audio rate at the top end, extremely slow on the low end. So that was something like, I was watching the timer, that's something like 17 seconds or something on the low end. So that's pretty cool. It also has two shapes. We're here in the square shape right now. Turning up the modulation amount. So the pitch is jumping up and down. It also has a triangle shape. Now this triangle shape is a little weird because I left it unbuffered. So it's got some DC offset, and it can be kind of hard to dial in. It only works sometimes at certain combinations of the audio oscillator pitch and the control oscillator rate. So I'll try and dial something in here. So there's some triangle. Turn the amount all the way up. So it even cuts out at some point. This is a weird experimental synthesizer, so not all the controls behave linearly across their entire sweep. I didn't mention this, I've referenced it, I haven't specifically mentioned it before, but the modulation amount controls the strength of the influence of the control oscillator, which we don't hear. We only hear its effects on the audio oscillator, which is the pitch that we do hear. Yeah, that unbuffered triangle is weird. There's kind of an uneven setting. The rise is faster than the fall. That's interesting. Alright, let me tone this down some. So that's been kind of voice one, but we've got three voices. So we have two more audio oscillators that do the same type of things. Here's bringing in oscillator 2. Get them kind of in unison, just by ear. Oscillator 2 is noisy. There's some crosstalk on the Schmidt trigger chip, just the way it is. And oscillator 3. Audio oscillators 2 and 3 have their own control oscillators that do their own thing with their own shape controls. So it can get pretty crazy. We're nice and drony. That's fun. Let's go back down to just oscillator 1. So the oscillators can interact, and this is inspired both by the Lyra and Casper. So they can FM each other. In this case, that's frequency modulate. So in this case, we're hearing audio oscillator 1. I'm going to let audio oscillator 2 change its pitch. And that timbre is changing based on the control oscillators, changing the pitch of the audio oscillators, which we're hearing. So we get 4 different timbres actually, depending on whether both control oscillators are on, both off, 1 is on, 2 is off, or 2 is on, 1 is off. So that's a little FM. We can also add the pulse shape from a second oscillator into the mix path of the first oscillator. So again, we're hearing audio oscillator 1. I'm going to add the pulse wave of oscillator 2 into the mix path of oscillator 1. And it's subtle. Start to hear oscillator 2 interfering. Here, I'll take it out again and back in. So lots of fun textures in there. The control oscillators can also interact. So let me get a good amount of control going into audio oscillator 1. It's going up and down very predictably. Just like the audio oscillators, control oscillator 1 can be frequency modulated by control oscillator 2. I'll do that now. Depending on their relative rates, there's something interesting. So control oscillator 1 goes fast when control oscillator 2 is low, and gets cut off when control oscillator 2 is high. The other relationship we can set up, turn that off now, is a link between the rates of the control oscillators. And this can be kind of subtle. It depends on them both being at kind of a medium rates and kind of opposite polarities, but it can result in some really cool irregular patterns instead of just going up and down at a steady frequency. Hear how the changes are uneven? It's kind of cool. I'll turn that off. Bring the other oscillators back in. Actually, I'll stick with oscillator 1 for just a second. So the mixer is actually has distortion built in. So when the volumes on the mixer are up to about 1 o'clock or so, 1:30, it's pretty clean. And after that, as you push it, the mixer starts to distort. Back that off again, and it gets especially interesting when you've got all 3 signals or multiple signals going in. So there's about the maximum clean level, and as we push up farther, so they not only distort, but there's bass blocking distortion, and the bass frequencies start to overwhelm the mixer circuit. They interfere with each other, they crowd each other out depending on what the lowest frequency is. Can be some really beautiful textures. Anyway, not everybody's speed. I love it. I think Dad's gonna love it. I'm gonna reset here and show you just a couple more features. Alright, I plugged in some other equipments. So the oscillators go through voltage controlled attenuators, low pass gates for the synth nerds, and they have what I'm calling a remote jack, where the voltage that opens the low pass gate is on the tip, and there's a return path on the send, and this is to facilitate external playing around, very Casper style, playing around with passive control of the synthesizer and bringing in other controls. In this case, I've plugged in just a simple toggle switch to the gate, and flipping the switch opens the gate, opens the attenuator. Simple as that. This can also accept resistance, a variable resistance, so 0 to 1 meg ohms of resistance between the tip and the sleeve on any cable that's plugged into the jack here. Finally, oscillator 3 has a primitive type of voltage control. So if I bring up oscillator 3, it also has a gate input, so you can control oscillator 3 with any type of controller that does volt per octave CV. In this case, I've got a key step plugged in. I'm going to play a little sequence. Bring in oscillator 2. Fun. also have a direct out, so you can use guitar pedals or anything to process the signal and record it externally, or bring it back into the mixer. The mixer has 3 inputs. They're normal to the oscillators internally, but you can override them, bring external signals into Mnevis. Finally, this is powered by standard guitar power, plus 9 volts and 0. There's an internal negative 9 volt rail, which is super, I've learned is super useful in synth design, specifically for buffering LFOs, also for the exponential converter that makes the volt per octave work on Audio Oscillator 3. But anyway, that's Mnevis. I'm going to be making a couple recordings myself this afternoon, and then delivering this to my dad. It's going to be his synthesizer for a while. I have a lot more ideas on this style, this family of circuits and synth design. I'm going to be taking a break from synth development to make music and live my life for a while. So I hope you've enjoyed this. I hope it's worked as a podcast. And take care. We'll see you in the next one. All the YouTube things, all the podcast things, like and subscribe. Contact me via the MrFuriousRecords.bandcamp.com contact form. Stream something from MrFuriousRecords.bandcamp.com or Datura Records.bandcamp.com. And we'll be back next week. Sorry for the long outro.